So, okay, so we're going to learn how to add an infinite geometric series. We cannot do an infinite arithmetic series, okay, but we can do an infinite geometric series. Once again, that may bother you a little bit, thinking that something goes forever and ever, and yet you can still add it. I think when you see some of the qualifications here, in order to add it, maybe it'll make a little bit more sense. And frankly, this is the easiest formula we've seen so far. The sum of the infinite series is equal to t sub 1 over 1 minus r. Now, guys, what is t sub 1?
First term.
Yeah, once again, it's simply just your first term. And then what is your r?
So change between them.
Yeah, that's right. It's the ratio. It stands for ratio, but it's certainly what you multiply to get the next number. So, let's now, here is the qualification that may make it a little bit more sense. Guys, we can only do this if your r is less than 1. And it's got to be the absolute value of r less than 1. What does that basically mean r has to be?
1.
Zero.
It can't be 1.
Zero.
Well, negatives, remember you're taking the absolute value, so negatives don't matter.
Decimal, a fraction.
It's got to be a fraction, or it really could be a decimal. So all of these r's have to be a fraction less than 1. You can't do 7 over 2, 3.5. That's larger than 1. So all of these, and this is kind of the unfortunate thing is that when we do this, your r is always going to be a fraction. But there are times where you can't do this, and you're going to see both of those today. When I can't do this. You can't do this if your r, absolute value of your r, is greater than 1. It's got to be less than 1. And that's really what my directions say here, guys. Let's find the sum. If the series has no sum, we're going to say that. Okay? And it's going to have no sum if that r, that ratio, while we multiply to get the next term, is larger than 1. It's got to be smaller than 1. So let's look at this first one. And really, because of this, guys, let's see if I can get this working here. Because of this, I always find my r first thing. So what's my r here for 64, 48, 36, and keep going through infinity? What would my r be? How would I find my r if I can't see it pretty plainly?
You divide.
Yeah, what do I divide?
64 by 48, right?
Opposite.
48 by 64.
Yeah, 48 by 64. If you remember from last week, if you can't find your r very easily because the numbers are a little bit different, then guys, you simply just put your second term over your first term.
3/4.
Okay, whoops, I'm going to do this. Sorry, I already did that. This is t sub 2 over t sub 1. So yeah, let's go ahead and simplify this. What did you do? Look, I did an 8 first, I think, right? So that's what, 6 times 8, 8 times 8, divide by 2 right now to simplify. So we got 3/4, right? Is 3/4, is the absolute value of that less than 1?
Yeah.
Yeah. So because it's a yes, I can go ahead and do this sum. So the sum equals, what is t sub 1 in this case?
64.
Yep, 64. It's my first term. Over 1 minus, what's my r here?
3/4.
Yeah, 3/4. Now we're just going to go ahead and simplify this. 1 is what? 4/4,
Yeah.
right? Minus 3/4, which is what?
1/4.
1/4. And then how you want to simplify that? Yeah, you can multiply both top and bottom by 4. That's kind of what I've been doing. When we did complex fractions, that's kind of how I taught it, was to simply multiply top and bottom by whatever that denominator is in your complex fraction. Because look, the 4's cancel out down here. What are you left with on the denominator? 1. Then 4 times 64 is what? 256, I believe. There you go. That's it.
Sounds easy enough.
Now, we talked the last couple classes, we talked about a different way to do this because I wanted to make sure, because I know we got some complex fractions here. You can do this. You can make that into a division problem. So 64 divided by 1/4. And then remember, when you divide by a fraction, you really do what? Multiply by the reciprocal, right? And 64 times 4 is what? And 256, you get the same thing. So whether you want to simplify that complex fraction or whether you want to change it to a division, not a problem. Either way. Okay, let's look. I got 2 more here. So first thing let's do, let's find my R. Can we see that real easy? No, so you want to do a fraction, right? What's my second term?
-6/3.
Yeah, -6 squared root of 3. My first term is what? 6. Yes, that's a negative because we're subtracting here. So 6's simplify, right? Just left with what? Negative square root of 3, right? Now, if I take the absolute value of that, is that less than 1? This would be what? Absolute value of 3 less than 1. What is the absolute value of 3? That's like 1.717. Is that less than 1? No. So guys, this one has no sum.
It's a lot easier.
Yeah. So anytime you get an R that's less than 1, you're going to have no sum, and you're definitely going to run into that on today's lesson. Now, last one's probably definitely the hardest, but it's not bad, guys. It's not bad at all. Let's start off with figuring out what my R is here. Does anybody know what my R is? We kind of talked about this the last couple days. Yeah, it's 1/10. You say, how do we know that? Well, we know that a geometric formula is T sub n equals T sub 1 times R to the n minus 1. And yeah, that's not n minus 1. But anytime we're taking that exponent, a variable exponent, whatever it's going to, that is going to be your R. So 1/10 is my R. By the way, is this R less than absolute value less than 1? Yeah, it definitely is. So we're okay to do our sum here. So the sum is T sub 1, over 1 minus R. R is 1/10. What's my T sub 1? What's my first term?
Oh, you have to plug in the x equals 1.
Yeah, that's right. Very good. Absolutely, Sam. We got to take this x equals 1. We got to plug it in here. So this is going to be 4 times 1/10 to the first power. What is 1/10 to the first power? Just 1/10, isn't it?
Yeah.
What's 4 times 1/10? That'd be 4 over 1. So that'd be 4 over 10, which I think we can simplify to be what? 2/5. Yeah, absolutely. So there's your first term. As ugly as it is, There is T sub 1. Okay, now 1 is what? 10 over 10. So 10 over 10 minus 1 over 10 is what? 9 over 10? So I get 2/5 over 9/10. Ooh, that's kind of ugly. What do you want to do there? Yeah, this one I think maybe is, and one of the reasons I brought it up is maybe this one's easier to change it to a division problem. Okay, 2/5 divided by 9/10, which would be what? 2/5 times what?
10 over 9.
10 over 9. And then what can you simplify here? 5 and the 10, right? So what do we get here? 2 times 2 is what? 4. 1 times 9 is?
9.
Yeah, so 4/9. Now somebody say, can I plug this in my calculator? You could. What you're going to get is 0.444444444 repeating, which is what 4/9 is. Once again, I'd probably rather you leave it as a fraction than as a decimal. Okay, especially since they give you fractions here. But that's it. A little less complicated of a formula. But you're going to do some of the same stuff. Okay, very similar. Questions? Let me see. All right, let me see if I remember this. I know it's 2, 4, 5, 8, 11 written exercises, and I'm pretty sure it's page 533. This thing can stop. Going a little wacko here. But I'm pretty sure it's page 533, 2, 4, 5, 8, 11. I'm right.
So many questions.
Yes, just 5 of those. We'll go over those. Actually, tomorrow we'll do a little review. Monday we'll do a little review also. And then I think the quiz will take Tuesday or Wednesday, because I think you guys have really short classes, I think.
Yeah, I think it's 9 minutes.
Yeah.
Yeah, what's the ECA?
Yeah, I step.
What's the point of even having some period for 25 minutes?